Periodic table. Here we'll discuss about Dobrinier triad, Newland's law of octave, Mendeleev's periodic law. Dobrinier's triad. Early attempt to sort the elements into some logical order by their physical properties. It consisted of a group of 3 elements. The appearance and the reaction of the elements are similar to each other. The relative atomic mass of the middle element was close to the average of the relative atomic masses of the other 2 elements. Example: lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine, sulfur, selenium and tellurium. Disadvantage of Dobrinier's triad. All elements discovered at that time could not be classified into this. Hence, it was discarded. Newland's law of octave. Elements arranged in increasing order of atomic weight. Every 8th element has properties similar to the first, like the 8th note in the octave of music. If the chemical elements are arranged according to increasing atomic weight, those with similar physical and chemical properties occur after each interval at 7 elements. Newland's was one of the first to detect a periodic pattern in the properties of the elements and anticipated later developments of the periodic law. Limitations of Newland's law of octave. Elements of atomic number greater than calcium did not fit in this law. Mendeleev's periodic law. The physical and chemical properties of elements are periodic function of their atomic weights. Chemical properties of elements recur periodically when the elements are arranged in the order of their atomic mass. Mendeleev's periodic table. Mendeleev created the first periodic table elements, which were arranged in the increasing order of their atomic mass. Elements with similar characteristics fall in same vertical columns called group. Blank spaces were kept for undiscovered elements. Drawbacks of Mendeleev's periodic table. Inert gases were not predicted. No spots for the inert gases. Certain elements were not placed in the order of increasing atomic mass. Concept of modern periodic table. Atomic number. Chemical properties of the elements are periodic function of their atomic number. Periodic table elements are arranged by increasing atomic number. Salient features of modern periodic table. Elements increase from left to right accordingly to their atomic number. Elements with similar characteristics fall in vertical columns called groups. There are 18 vertical columns. Elements are arranged in 7 horizontal rows called periods with increasing atomic numbers from left to right. Vertical columns of periodic table. Vertical columns of periodic table have same number of valence electrons. Elements of same group have same chemical behavior. Elements of group 1 have 1 valence electron and are called alkali metals. Elements of group 2 have 2 valence electrons and are called alkaline earth metal. Elements of group 17 have 7 valence electrons and are called halogens. Elements of group 18 have 8 valence electrons and are called noble gases or inert gases. Horizontal rows of periodic table. Horizontal rows of periodic table are called period. In the period, elements are arranged in increasing atomic number from left to right. In the period from left to right, the nuclear charge increases, but the number of shells remain the same. Elements with same number of shells are placed in the same period. Gradual change from metallic to non-metallic character from left to right in a period. How to decide the group of an element. Number of valence electron determines the group. Number of valence electrons is 1. Element is in group 1 or 1a, alkali metals. Number of valence electrons is 2. Element is in group 2 or 2a, alkaline earth metals. Number of valence electron is 3. Element is in group 13 or 3A. Number of valence electrons is 4. Element is in group 14, 4A. Number of valence electrons is 5. Element is in group 15, 5A. Number of valence electrons is 6. Element is in group 16, 6A. Number of valence electrons is 7. Element is in group 17 or 7A, referred as halogens. Number of valence electrons is 8. Element is in group 18 or 0, referred as noble gases. How to determine the period? Valence shell determines the period. First shell is the valence shell. Element will be in period 1. Second shell is the valence shell. Element will be in period 2. Third shell is the valence shell. Element will be in period 3. Fourth shell is the valence shell. Element will be in period 4. Finding position in the periodic table. Example: silicon, atomic number 14, electronic configuration 284. Valence shell is the third shell, so period is 3, and the valence electron is 4, hence group is 14. Finding position in periodic table. Helium, atomic number 2, electronic configuration 2, period 1, group 18. Oxygen, atomic number 8, electronic configuration 2, 6, period 2, group 16. Sodium, atomic number 11, electronic configuration 281, period 3, group 1. Calcium, atomic number 20, electronic configuration 2882, period 4, group 2. First 20 elements of the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Comparison of alkali metals, alkaline earth metals, halogen, and inert gases. Alkali metals are group 1 elements, while alkaline earth metals are group 2 elements. Halogen group 17 elements and inert gas group 18 elements. Alkali metals have 1 valence electrons, form +1 cations, and have the least ionization energy in the period. Alkaline earth metals have 2 valence electrons, form +2 cations, and have a higher ionizing energy in a period. Halogen have 7 valence electrons, forms -1 anions, have a higher ionizing energy than metals in a period. Inert gases have 8 valence electrons, neither form cations nor anions, have the highest ionizing energy in the period.